Okay, welcome to Innate and Adaptive Immunity. Let's get started with a quick overview and then we'll take a closer look at what this actually looks like. So, innate immunity is the first immune response that the body triggers. What happens is a macrophage, this big type of white blood cell that's always floating around the body, recognizes a pathogen and activates this pathway. The receptors on the pathogen are not recognized by the macrophage, and it looks at it and says, "You do not belong here. I don't know what you are." So then the macrophage begins phagocytosis, which is the process of basically ingesting the pathogen. It takes the entire pathogen inside its cell and then kills it. After it does that, it releases cytokines, which can cause inflammation, and the inflammation is to help to contain the pathogen or infection. Inflammation calls over more phagocytic white blood cells to help. And what you see with inflammation is redness, swelling, heat, and pain. Usually it stays in one area. As more cytokines are released, if this little infection does not go away quickly or is not taken care of quickly, the cytokines can cause fever, lethargy, or tiredness, and decreased appetite as the body tries to keep resources contained to fight the infection. After phagocytosis, the macrophages give the antigens from the pathogen to dendritic cells to go and help using the adaptive immune pathway. So adaptive immunity starts with the dendritic cells. They take these antigens from the macrophages and then they have to go away. They have to go to the lymphatic tissue where T and B cells kind of just hang out waiting to be asked to help. The dendritic cells then present their antigen to all the T and B cells that are just kind of hanging out until they find the ones with matching receptors. When they find the matching receptors, those T and B cells are then activated and sent to the site of the pathogen to help out the poor macrophages who are trying to battle with phagocytosis and inflammation. The T and B cells then join the fight, and because they have these receptors and they already know what these pathogens are, they can help more specifically and readily. So they are over there finally fighting along with the macrophages and other white blood cells. Other cells called T helper cells become activated as well, and they lead to the development of other cytotoxic T cells that help the immediate fight, but they also trigger the development of antibodies and memory B cells to help in future battles with this particular antigen. Okay, now let's take a look at what this actually looks like inside the body.
Okay, I am a macrophage. I just circulate through the body just to kind of keep an eye on things. And what have we here? We have pathogens. These do not belong here. I don't know what these are. I do not recognize these. Okay, I am going to start freaking out now. All right, I have dendritic cells, my little dendritic cells. Come on, I'm going to need your backup in just a second. Okay, I gotta figure out what to do. So the first thing I'm gonna do is I'm gonna take one of them and I'm just gonna eat it. I'm just gonna eat it. I'm just gonna eat it. Yeah. Oh, that's good. That's good. Okay, good. All right, I ate that one. I'm just gonna eat another one. This is called phagocytosis. Taking the bacteria into myself, and then look what they left behind. I have these things. Okay, my dendritic cell friend, I'm gonna need you to take those. Thank you very much. Okay, I have killed my first two pathogens, taken those markers on them, given them to the dendritic cells, sent the dendritic cell off to the lymph nodes and the lymph tissue to go find me some T and B cells that can help me fight this pathogen off, because I can't do it by myself. In the meantime, though, I need a little bit more help that is still non-specific or innate. So I'm going to send out signals called cytokines, and I'm going to call the cytokines and say, hey, help me out. And what are the cytokines going to do? They're going to try to contain it by building a wall or causing some inflammation. So the inflammation contains the pathogens. So they're going to send out signals. They're going to start building the wall. Build the wall, build the wall, try to contain it. Inflammation is not perfect. It isn't impermeable, but it'll do the trick for a few minutes or a little while while we're waiting for the T and B cells to come back and help out with fighting this. Some of these pathogens could get through, which makes the T and B cells' jobs even more important. Okay, I am a dendritic cell. I have these two antigens that the macrophage gave me when it phagocytosized, performed phagocytosis on the pathogen. And now I have gotten to the lymph tissue and the lymph nodes. I'm here with some T and B cell pairs, and I need to find the T and B cells that match my antigen so I can take them back and help the macrophage fight the pathogen. So I'm looking at all of these, and I can see that this one, I have some nice purple antigens here. These are nice and purple. Let's see, so my first T and B cell combination, oh, these are not purple. These are pink. These are pink. They're not going to work. They're not going to work. Sorry, guys. Save you for another day. Okay, so this pair up here, not the same. These are blue. These are blue antigens. They're not going to work either. Okay, how about over here? We've got these. Oh, I dropped my antigen. This antigen is green. It is not the same. Nope, sorry, buddy, not today. Okay, so I hope this one works because this is my last one. Here's my antigen. Oh, yep, this pair works. All right, I'm gonna take this. I'm gonna take this group of T cells and B cells with me back to the site of the infection with the pathogen, and we're gonna go see how the macrophage is doing. Okay, I am now a T cell. I have these matching little antigens on me. And the dendritic cell has told me where to go, and I am now here where all of the pathogens are. And because I have these little things, I recognize them, and I go up, and I match up with them, and I can kill them. And because I'm so specific, I know exactly how they should die. Take them all down. I'm going to take them all down. I'm going to take them all down. All right. Okay, I am now a B cell. Like my T cell that I came in with, the dendritic cell brought me in because I have little matching receptors, and I can walk over to this pathogen, and I know that I know how to take care of it. So because my markers match up, so I take one and kill it. I also have other jobs. So a B cell can also stimulate memory B cells to be made so that I can make more of me, just like me, to help control and circulate a little more widely for this specific pathogen. The other thing that I get to do as a B cell is to make antigens. So as I am activated and deal with that pathogen right there, I make antigens, and the antigens just free float around the body looking for these pathogens. It's around there. We don't know exactly where, but each time that my antigen sees it, it can grab onto it and alert the cells around it to grab one of those memory B cells, and the B cell can come over and kill it.